Hi, Sarah. Oh. Nice. 3.1 is functions. This is a worksheet for homework, so I don't have the homework assignment printed at the top. This is a worksheet. We're going to get through maybe quite a bit of this. I don't know. We'll see. We'll see. But these are functions. They're going to baby step us into chapter 3. And they're talking about inputs versus outputs. And typically when we're dealing with functions, wait a second. Okay, hold on a minute. Or frozen. There we go. There we go. No. Hold on. Haha. There we go. Nope. There we go. Normally when we're dealing with inputs and outputs, the inputs are the X's and the outputs are the Y's. The inputs are the X's, the outputs are the Y's. Okay, that's kind of how they set up a function. Describe the set of inputs, the set of outputs, and the rule for the following functions, okay? A, the amount of income tax you pay depends upon your income. So which one is the X and which one is the Y? The amount of income tax depends on your income.
So X is the one that is the Y depends.
Yes, income tax is your Y variable. Your income would be the X, right?
Correct.
Okay, so the rule for that would be like Y is equal to some interest rate times your income. So Y equals some rate times X, whatever the income tax rate is. Okay. B, suppose a rock is dropped straight down from a high place. Physics tells us that the distance traveled by the rock in t seconds is 16t squared. The formula is Y equals negative 16t squared plus like D, which is the distance that you drop it from. Okay, we've seen that formula before. T is your X variable. Y is your output variable. So the time is the independent variable, or your X, and the distance that it travels is your Y, that the rock travels. Okay, so that's kind of how that works. Suppose a rock is dropped straight down. Yep. Part C, the Weather Bureau records, I think part C is referring to this diagram over here. The Weather Bureau records the temperature over a 24-hour period. Note that they have listed it in military time, so they're going 0 to 24. The graph shows the temperature that corresponds to each given time. So this is showing us that the lowest temperature is at 24, which would be at where? Midnight, right? This is at midnight.
Good job, Jason.
Hour number 24.
Oh, the
lowest temperature? Nope. The lowest temperature is there, which is probably maybe at 24 degrees, right? This would be, nope, wrong. This would be at 30 degrees, so it'd be like maybe 34 degrees, something like that, okay? The highest temperature occurs probably right here at maybe hour number what? 15? 15? Let's say hour 15. What is hour 15?
3 o'clock.
Hour 15?
It's 3 o'clock.
Hour 12 would be noon.
Yeah.
Hour
3 o'clock.
15 would be 3. Did you say 8 o'clock?
I said 3 o'clock.
Oh, I heard 8 o'clock. Did you not hear 8 o'clock come out? Okay, whatever. 3 p.m. I don't know. I can't hear. My ears are so clogged. 3 p.m. is when it is the highest temperature, etc. Right? Okay, the Weather Bureau records the temperature over a 24-hour period. The graph shows the temperature that corresponds to each given time. Which one is the X variable?
The X variable is the time.
The time. These are the X's. The temperature is the Y's. So those are the inputs and outputs. Yeah?
Yes.
There you go. Okay, moving on. Definition of a function. They will start to represent functions as like f of x rather than y's, right? F of x, so we can plug stuff in. All right, a function consists of a set of inputs called the domain and a set of outputs called the range. That's these two bullet points right here. A rule by which each input determines one and only one output.
Yeah.
Right? Yeah. If the x values repeat,
Then it's
not
a function.
Then it equals not a function.
So number 1 would.
Okay, if the x values repeat, it is not a function. All right, the table below lists the inputs and the outputs of the two relations. Let's do A first.
It's not because the 2 1.
Let's do domain and range. I don't know if it asked for that, but there we go. That's what we're going to do. Domain.
1, 2, 3.
1, 2, 3. We don't have to list any of them that repeat. We don't have to list them twice. The range, 5, 6, 7, 8, 9. Okay, function or not a function? Not a function. Okay, true or not true?
True.
If the domain has fewer elements, listen, if the domain has fewer elements than the range, it will definitely for sure not be a function.
Yes.
True.
True.
True. If this has only 3 elements in it and this one has 5, for instance, definitely not a function, right? Then one of these would have to repeat twice at least, right? Okay, so definitely not a function. All right, B, domain and range.
1, 3, 5, 7, 9.
1, 3, 5, 7, 9. Range?
5, 7, 8.
5, 7, 8. Function or not a function?
Yes.
Yes, function. Because even though the range repeats, it doesn't matter. Yes, it's a function. Okay?
Yes.
All right, they're giving us a rule for a function. F of x is defined as the square root of x squared plus 1. And they want us to find f of 3. What does that mean? Plug 3 in. 3 squared plus 1. Whenever you are plugging values in, make sure that they are always in parentheses.
3.1.
This is the square root of
That's my guess.
10.
10, and we're going to leave it as the square root of 10 if it doesn't come out nicely. You leave it as the square root of 10. We don't solve it as a decimal. Next, the square root of negative 5 squared plus 1.
20, the square root of 26.
26.
Okay, because when you square a negative,
It's positive.
it always becomes a positive. If you don't put it in parentheses in your calculator, it will not put it as a positive number. The square root of 26, we're going to leave it.
Calculator's done.
Okay? All right, this
One.
one. The square root of 0 squared plus
Is the
1
Square root of 1.
is the square root of 1. What is the square root of 1?
I thought the square root of 0 was 1.
No, that's if it's to the
That's the
0
square root of
power.
negative 1. What's the square root of 1?
1.
What do you take times itself to get 1? Is it plus and minus 1 or just 1?
1.
Why?
Because we didn't put that in there.
We did not insert the square root, so it is only 1 and not positive negative 1. Make sense?
Yep.
Yes? Great. Okay, moving on. This is something called a difference quotient. You have to do this on your homework assignment. Are you ready for this?
Yes.
This right here is something called a difference quotient. Difference quotient. Write this down. This is something called a difference quotient. This is calculating a derivative, which you will do in calculus if you choose to take calculus next year. This is the definition of a derivative, okay? Before we learn all the shortcut rules to it. But this is how you find a derivative, okay? You calculate what's called the difference quotient, and then you take the limit of it. Okay, you don't know what that means, but that's what you do in calculus. All right, they are going to, hold on, they are going to baby step you through this, and they are going to say, this is ultimately what we're trying to find over here on part C. That's ultimately what we're trying to find. But they baby step us because they start with, let's just find f of x plus h. Let's just do this part first, right? Then let's calculate f of x plus h minus f of x, which is this top part. Then in part C, we're finally dividing it by h, right? So they're baby stepping us through this. We're basically doing 3 things, but we combine them together. It's like consecutive, okay? So here we go. The function that we're doing is x squared minus x plus 2, yeah?
Yeah.
Okay? And what does it mean when it says f of x plus h?
That's what you plug in for x.
That's what you plug in for x. So this part A is going to be pretty big. So start off to the left quite a ways. X plus h, we're going to square that. Minus x plus h plus 2. Like we're just plugging that stuff in. Do you see where I'm getting that number, those numbers from? Yeah? Okay. No? No? Okay. X squared minus x plus 2. We're taking this thing and we're plugging it in there and we're plugging it in there. Do you see that? Yeah? Okay. That's what we're doing. All right. Now that first part, x plus h squared, we have to
multiply.
foil. We have to foil.
Plus 2h.
Okay. Hold on. So x times x is x squared. X times h is xh.
Oh, just kidding. 2x.
X times h is another xh, or hx, plus h squared. Okay, so we can combine those middle 2 terms. We get x squared plus
2hx.
2xh, or 2hx, I don't care how you write it, plus h squared. Okay, that's just this chunk. And then what about the second piece?
Minus that. Foil the minus.
FOIL the minus, so minus x minus h. And then we have plus 2. That's my 3 pieces that I have going on there, and then we're going to simplify. But I don't know that we can really simplify a whole lot. I don't know.
Okay.
We can't simplify anything?
No.
So that's it. That's part A.
illegal.
I hate
That's
that.
disgusting.
Why is it
Didn't
that
even
dumb?
find anything.
Yeah.
We didn't even really find anything. That's because there's baby stepping us through it. Then part B, we're elaborating on that, right? Part B is f of x plus h. We just found this guy, and then we're subtracting f of x, okay?
F of X.
So we're taking this guy over here, and we are then subtracting f of x. What is f of x?
Negative x.
Yeah, it's this guy right here. We're subtracting x squared minus x plus 2. That's what we're doing in the second part, okay? Okay, confused, right?
I got it.
We got it? We got it?
Because of f of x is equal.
F of x is that set part. So we're subtracting that. But the first thing that we have to do first is distribute the negative, right? So minus x squared plus x minus 2. And we're going to add this stuff, and we're going to combine them together, and we're going to put an answer down here. Okay? And I'm too lazy to write it twice, so I'm just going to write it like that. Okay? All right, it gets rid of the x squareds. He's gone, right? Okay.
Negative 2.
What else does it get rid of?
The x.
Minus is an
The
X.
No.
Plus x minus x. What else does it get rid of?
2.
Minus 2 plus 2.
What the-
Do you see that?
2x plus h squared.
2xh plus h squared minus h. Okay? That is what that second part is, right?
So now you just
Okay.
divide
Then you
by
put it
h.
over
The
here.
last thing is this guy, and that we've just calculated. We calculated this part in part B, so we literally just do that. 2xh
You just
plus
divide.
h squared minus h all over h, right?
But H is-
Okay.
H is 0.
Now hold on
H
just a second.
cannot be
H
0.
cannot be 0, so don't worry about that. Okay? How many pieces are in the top?
Three.
What do all 3 of those have in common?
H.
H. Let's pull an h out in the front. So we have 2x plus
H.
h minus
Hold
One.
up.
1 all over
H.
h. And we cross that out.
So it's 2x plus H minus 1? That's
Yep,
the answer.
really it's 2x minus 1 plus h. But anyway, because the derivative of this thing is 2x minus 1. Because we plug 0 in for h, but that's finding the limit, and we don't have to do that here.
So
So
it's just 2x plus H?
2x minus 1 plus h, or 2x plus h minus 1, yeah. That's the difference quotient. That's our
Well,
final
it's easier to
answer.
do minus 1.
This is the proper way of writing it.
Minus 1 plus H?
Yeah, we usually write the h at the end because we end up plugging 0 in for h anyway when we have calculus. So,
Alright, cool.
so that's how that works. Yeah?
Yeah.
Happy with that?
Are these gonna be answer list problems? Like,
Is this whole chapter
Yes.
gonna be like
Well,
this?
what?
Kinda
What do you mean?
you're
Answers.
not finding like
Finding
an x
anything.
equals, you're not finding that. Like,
Yeah,
you're not having an x equals.
This is what you were doing right here. You have an answer
Yeah,
here
I mean-
and
I
an answer
mean,
here.
like the-
But when you're doing
Find the
difference quotient, it will generally always have an h in the answer. I shouldn't say that. It will not always have an h in the answer.
Is this more calc stuff?
But generally, it will have an x, maybe not in the answer. I don't know.
So it won't be like, you're not finding just what a variable is equal.
Right,
Okay.
right,
Yeah.
right. Yes, you're plugging stuff in. Yep, and you're reducing. Okay. All right. Example 5. Determine whether each equation defines y as a function of x. Okay. So we're trying to determine whether or not these are functions or not functions.
No.
Okay. So here's what's going on. Okay, you're trying to get like y by itself, and if I would do that, I'm going to bump this y to the other side, right? So I would have like 4x plus 5 is equal to 2y cubed, yeah?
Yeah.
Okay, and then what would you do?
Divide by 2.
Divide by 2, right? Okay,
Take the cubic root of
which
that.
doesn't come out very nicely, so we're just going to leave it like that, and then we would end up taking the cubic root of that at some point, right? And that would give us y. Y is the cubic root of that junk, right? Okay, do you know what a cubic root looks like?
Yeah.
Like, what does it look like when you graph it?
This.
Oh, then no.
What does a
it's-
cubic
yeah,
root
it's
look like?
a W.
It has, it's a,
Yeah, it's a W. right?
That's an x cubed,
like a slide.
so turn it on its side. This
So
is a
it's not
cubic root.
function.
That's a cubic root.
Oh, it is.
That's what I
Oh, it
said.
is a function.
Is it a function?
Yeah, because you can do the vertical.
Okay.
thing.
Yes.
So how are we supposed to know this if it's
Yeah, I
function or
remember
not?
stuff.
I don't ask you any of this on your homework assignment, but anyway. Nope.
How hard do you-
Okay, Moving on.
You got
Yes?
lost by Reese.
Okay, next. This next part. Okay, here's what I'm gonna do. All right, I'm gonna do this. I'm gonna solve for x in this case. I'm gonna get the x by itself, so we're gonna bump the x over. So y squared equals, or no, excuse me, y squared plus 1 equals x, right?
Yeah.
All right, we know what y equals x squared looks like, right?
It's a
Y
parabola.
equals x squared is a parabola right here like this,
So
right?
it's gonna be probably like
What is x equals y squared?
a sideways
A
one.
sideways
Is a
parabola.
sideways parabola.
So it's not
Like this, something of that nature, right? Function or not a function?
not a function.
No.
No, so B is a no. Yeah?
Yeah.
Make sense? All right.
Is the whole chapter gonna be like this? Because I like it.
I mean,
I
it starts to
actually
get
don't
harder
want
right
to-
now.
Or-
Ish. I mean, maybe a little bit hard, a little harder than it was before.
But the
I don't think
domain-
as hard as the difference quotient. That's maybe the hardest thing that we've done.
X
All
can't be one.
right. Now, this next part is something that we will use the rest of this chapter, and it is called finding the
So we
domain.
gotta list-
Okay? Here we go. Listen to this, and I will use this in Trig. I'll use this again in Calc. We'll talk about this. And I say, what two things screw up the domain? These are called domain errors.
0 and negative.
Yeah, these are called domain errors. Some of you guys know these already. Like, basically, what are we not allowed to have in a function?
0.
We're
and
not
negative.
allowed to divide by 0, right? So, like, if it's 1 over x, for example, we would say x cannot be 0, right? We don't want to ever divide by 0. So, division by 0 is one of the domain errors. The second thing that I
A
cannot
negative
have
inside the
is a negative inside of a square root, right?
Yeah.
Okay? So, if I have, like, the square root of x, we would say x has to be greater than or equal to 0. Okay? Now, which one of those is easier to deal with?
The first.
The first.
The first one. This one's easy for the most part. This one's a touch harder. Okay? Because the first one is only looking at specifically what x cannot be. Right? The second one is like a range of values that we're only allowed to plug in for x, right? Because x being 0 only occurs at one value versus x being negative occurs at a bunch of values, okay? So the first one is easier to deal with, the second one is harder,
So
all
you're
right?
saying the first one
So
is like a
A
light little
can't be
tap,
one.
and the second one's
Can you
like
have a
shove
0
down the
on
stairs.
it?
Yes, exactly. The first one's a light little tap, the second one's a shove down the stairs, exactly, right? Okay, let's go on here and let's find the domain of each function, okay? So, part A, this is domain error number 1. Error number 1.
All real.
X
Okay.
cannot be 1.
Okay, so for domain, x can be anything it wants to be, but you guys are saying x cannot be 1 because if I would plug 1 in here, 1 minus 1 would give me 0, yes? And we cannot have 0. We don't even care about what the top is. I don't care about the top. The only thing I'm looking at is the bottom, okay? Now, what happens if I instead say, like, 3 over 5x plus 4? Now what can x not be?
Negative. No.
Can't be 1.
Okay, here's what you do. Are you ready? If you cannot do it in your head, here's what you're doing, right? You would say that 5x plus 4 cannot be equal to 0, right?
Yeah.
Okay, and then you just solve for x, right? So you would subtract the 4.
It can't be negative.
I would
5x can't be negative 4, right?
I was close.
Okay, and divide by 5, so we would say x cannot be negative 4/5.
I was
So if you
close.
can't do it in your head, all you do is set that bottom not equal to 0 and solve. Like you
So
would
can we
set
write
it
the
equal to
answer
0,
just
right?
like that, or do you want
That's how I want you to write the answer.
all reals but that?
The all real part is implied.
Okay.
So for domain, by saying x can't be 1, you're implying everything else except 1. So you just have to put x is not equal to 1.
Okay.
Yep. Does that make sense? Okay. All right. Part B is a little bit harder. Okay. You ready?
It can't be negative 3.
Yes. Okay. So part B. This is a little bit harder, and here's how this works. So the first thing that I want you to do is step 1. Step 1. I'm going to show you like the step-by-step instructions on how to solve domain error number 2. Error number 2. Okay. Good. Ready? Error number 2. The first thing is set the inside equal to 0. We set the inside part equal to 0. Okay, so u plus 2 equals 0 and we solve. u equals negative 2. Okay? And then I'm going to say find the correct range of values. Okay, find the correct range of values. So what I'm going to do is I'm going to slap negative 2 on a number line. And we're going to pick points, kind of similar to what we did in the last chapter. So over here, we're going to pick negative 3. Over here, we're going to pick, always choose 0 if you can. Okay, and we're going to say what are we allowed to have and what are we not allowed to have. So if I plug negative 3 in here, negative 3 plus 2 is negative 1. Can I take the square root of negative 1?
No.
No, so I cannot have numbers that are less than 2, negative 2. If I plug 0 in,
Yes.
0 plus 2 is the square root of 2. Can you do it?
Yeah.
It's not a nice number, right? But you can have the square root of 2, so that works. So I can do that one. Okay, so for domain,
Negative 1.
whoop,
X is greater than or equal to negative 1.
x, nope, negative 2. X is greater than, can it be equal to negative 2? Can I plug negative 2 in there exactly?
Yeah.
What is negative 2 plus 2?
0.
Can you take the square root of 0?
Yes.
Yeah.
It's 0.
Okay, so x has to be greater than or equal to negative 2. That's your domain.
Can we skip example 7?
X has to be greater than or equal to negative 2. 100%.
There's too many words and too many numbers and too many letters for number 7.
Okay, but I'm still on number 6. Are we okay? Are we clear on number 6?
Yes.
6 is okay?
Yep.
Yes? Okay. All right.
Number 8.
Number 8.
Okay,
Number 8
sure.
looks
I don't
great.
care. Whatever.
Yay.
Example 7. We can cross it off. I don't care. Okay, evaluating a piecewise function. This is probably maybe the first time you've seen a piecewise function other than the ACT or MAPS testing.
I
hate
hate
the
the
ACT.
Okay, I had a really heated argument with
Crap, I
Mr.
took
Arms
one.
about piecewises.
Okay.
He did them in there, but that was like way
Okay.
a long time ago and done.
Piecewise functions. Piecewise functions are when you have two functions that are fighting with each other. Kind of. Okay, two functions are fighting with each other. So, this function and this function are trying to occur at the same time. Yeah? The piecewise functions are not hard. Okay, so this thing is the domain. This tells you when you use each one of the functions. So, if the number that you're trying to plug in is a number that's less than 4, guess what?
Doesn't work.
You're going to
It
plug it
won't
into the
work.
top.
Oh,
If that number is a number less than 4, you're going to plug it into the top. If the number that you're trying to plug in is a number between 4 and 10, guess what? You're going to plug it into the bottom function. That's
easy.
all, right? So down here,
What if it's oh no.
just wait. We'll get to that, okay? So if it's a number that's less than 4, you're going to plug it into the top function. If it's a number that's between 4 and 10, you're going to plug it into the bottom function. Now, what if it's 4 exactly?
Then you have to do both.
Plug it into the bottom one because it's equal to.
Because it's
the
equal
bottom.
to 4 on the bottom. It's not equal to 4 on the top, right? If it's
Wait,
4
what if it's
exactly,
greater than 10?
hold on, just wait. We'll get to that. Okay? All right, so negative 5 is the first number that I'm going to plug in, okay?
Top.
Is negative 5 less than 4 or between 4 and 10? Less than 4, so I'm going to plug negative 5 in there. So I do 2 times negative 5 plus 3.
-7.
Negative 7. There you go. That's all. Piecewise functions are not hard. F of 8. Is 8 a number that's less than 4 or is it a number between 4 and 10?
63.
So 8 squared minus 1 is 63. That is f of 8. Yeah, you don't plug it into both functions. You only plug it into the one that he needs, right? Okay, and then we talk about the domain. So what am I allowed to plug in and what am I not allowed to plug into this piecewise function?
I have no clue.
Okay,
You
can I
can
plug in any number I want to?
Yeah.
It has to be less than 10.
We have a rule for any negative numbers, right? Any number that's less than 4 will work, right? I have a rule for any number between 4 and 10, but what happens, you guys have already asked me, what happens if a number is greater than 10?
Can't be
You can't do it. So we are only allowed to plug in x's that are less than. Are they equal to 10?
Yes.
Yes, because I can plug 10 in exactly because of that equal sign. So x's have to be less than or equal to 10. If it's 11, there's no answer, right? You would have no solutions if you're trying to plug, like you could add that over here, like f of 11 equals no solutions because I don't have a rule for 11, right? I don't have a rule for that. Okay, make sense?
Yes.
Yes? Okay, there's that.
Yeah, worksheet.
All right, last thing, here we go.
Rounding down.
Yeah. Example 9 is talking about the greatest integer function, okay? The greatest integer function is you always round down, okay? And here's an example that I always refer to when I'm thinking of greatest integer function. It is your age, okay? Your age is always rounded down to the age that you are, okay?
No, I'm gonna start rounding up.
Nope, here you go. So, if
Yeah,
you
right
are
backwards.
16,
61.
You're 17?
how old are you guys? 17?
I'm
Most of you are 17? Okay, well,
16,
No,
I'm
we're
older
rounding
than
up.
you.
Majority.
I'm
Okay.
17.
all right, so your age.
If we rounded up.
If you are 17 years and like 30 days, that's like a month past your birthday. How old are you?
18.
You're 17, okay? If you are 17 years and
11 months.
364 days, how old are you?
18.
You're still only 17
I
years
count at
old.
18.
No matter how many days have elapsed, I mean, as long as it's under a year, you are still rounding down to 17 because you have not yet
We
hit
start rounding
18.
up when it's
Does
like
that make
2 months
sense?
before my birthday.
Now, what you should do, all right, I get that it's easier probably to round up or to say my birthday is tomorrow, right? But you're always rounding down, regardless of that decimal. Okay, so this means like regardless of the decimal, like let's say you have 3.8.
3.
It's 3, you round it down to 3,
No, we
okay?
don't. We round that up.
No,
Yeah.
greatest integer means you always round down. All right, now,
Five or more,
let me
add one
show you.
more or less, let it rest.
let me show you the notation that they use. Watch. The notation that they use for greatest integer is like the box. So they put it in a box, and that means round down to 3. Some textbooks do it differently. Some textbooks will do this. They'll do 2 boxes.
Well, that's stupid.
That notation means exactly the same thing. Okay, so sometimes they'll do 2 boxes instead of 1. All right, here's the tricky part. Ready?
No.
Let's say they have negative 5.2, and they say, what's the greatest integer of that?
Negative 5. No, negative
No,
6.
it's
negative 4.
It's negative 6.
You're rounding down, right? You're rounding down. What's rounded down from negative 5.2?
6.
Negative 6. Does that make sense? So when it's negative numbers, think of a number line, right? Okay? Like here's your number line, here's where 0 is, here's where negative 6 is, here's negative 5, negative 5.2, right? Is there. We're going to round down to
That is.
negative 6, right?
But it's whack.
So negative numbers you kind of have to think about because they're negatives and they're automatically giving you weird things. All right, so here we go. Greatest integer of negative 4.7. What's that?
5.
Negative 5. What's the greatest integer of negative 3? Negative 3. What's the greatest integer of 0?
0.
0. What's the greatest integer of 5 fourths?
1.
1. Because 5 fourths is 1.25.
Yep.
Okay. What's the
Pi.
greatest
3.
integer of pi?
3.
3. Yeah, you're always rounding down. You're always rounding down.
I like the
Okay,
the whole
good.
chapter.
The whole chapter, the whole lesson. I don't know.
Schmitty got
Hopefully it stays that easy. I don't
These
know.
are the ones I'll get
Graphs
right
of
now.
functions. There we go. Okay, good. Happy with that? Everybody say bye, Sarah.
Bye, Sarah.